Welcome to your definitive guide on Group 7, the halogens. This topic is a cornerstone of GCSE Chemistry, appearing consistently across all major exam boards. The halogens are highly reactive nonmetals found on the right-hand side of the periodic table, just before the noble gases. Understanding Group 7 is critical because it bridges fundamental atomic structure with observable chemical reactions. Examiners love to test your ability to link macroscopic properties like color and physical state to microscopic explanations like electron shielding and intermolecular forces. This topic also introduces essential synoptic links to redox chemistry, requiring you to explain displacement reactions in terms of electron transfer. By mastering this guide, you will be fully prepared to tackle exam questions with precision and the terminology examiners reward. Let's map out the physical properties and trends of the halogens. At room temperature, fluorine is a pale yellow gas, chlorine is a yellow-green gas, bromine is an orange-brown liquid, and iodine is a dark gray solid that sublimes to a purple vapor. As you go down the group, the melting and boiling points increase. Why? Because the molecules become larger with more electrons, leading to stronger intermolecular forces, specifically London dispersion forces. More thermal energy is needed to overcome these forces, so the boiling point rises. Also, reactivity decreases down the group due to increased atomic radius and shielding effect, which reduces the attraction for an extra electron. Turning to our core study notes, halogens exist as diatomic molecules, meaning two atoms covalently bonded together. This is essential when writing balance symbol equations, for example Cl2. When a halogen gains an electron, it forms a halide ion with a 1 charge, such as chloride Cl-. A halide is also a compound containing a halogen and another element, like sodium chloride. Examiners will often ask you to name the product of a reaction, so remember, if it contains a halogen, it's a halide. Now let's examine displacement reactions, a core concept. A more reactive halogen can displace a less reactive halogen from its halide compound. For example, chlorine water added to potassium bromide solution produces potassium chloride and bromine. The ionic equation is Cl2 plus 2Br, 2Cls plus Br2. This is a redox reaction. Chlorine gains electrons and is reduced, while bromide loses electrons and is oxidized. The reactivity trend explains why chlorine can displace bromine and iodine. Bromine can displace iodine, but iodine cannot displace any. Remember to explain displacement in terms of electron transfer to secure top marks. Let's work through a typical 6-mark exam question. The question: describe what you would observe when chlorine water is added to potassium iodide solution. Explain the reaction in terms of electrons. First, state the observation. The colorless solution turns brown because iodine is formed. Then write the balanced equation, Cl2 plus 2Ki gives 2KCl plus I2. Finally, explain the redox. Chlorine gains electrons and is reduced, while iodide loses electrons and is oxidized. This step-by-step approach ensures you cover all marking points. Watch out for common pitfalls. Many students confuse halogens with halides. Remember, halogens are the elements themselves, while halides are the ions or compounds. When describing displacement reactions, always mention the color change, for example from colorless to brown when iodine is produced. For reactivity trends, you must explain using atomic radius and shielding effect. As you go down, the outer electron is further from the nucleus and more shielded, so it is less easily gained. Also, always include state symbols in your equations to show full understanding. To wrap up, remember the halogens are diatomic nonmetals with distinct colors and states. Their boiling points increase down the group due to stronger intermolecular forces. Reactivity decreases because the atomic radius increases and shielding reduces the attraction for an electron. Displacement reactions are redox processes where a more reactive halogen displaces a less reactive one from its halide. Always link observations to electron transfer. With these key points, you are ready to tackle any exam question on Group 7. Good luck!